So we reached the great result that after 2 centuries of energy transition, Britain, which is of course the leading countries of energy transition, the first industrialized country and the first country getting out of fossil fuels. I mean, they pretend actually. Britain used 4 times more wood to produce their energy now than in the 18th century. And just to produce 1.5% of their energy.
Welcome back to Decouple. Today I'm joined by Jean-Baptiste Frézeau. Jean-Baptiste is a French historian of science, technology, and the environment. I believe the correct term is a historiographer of energy, and the author of several books, but the one we're here to discuss today is en français, Sans transition, nouvelle histoire d'énergie, with the provocative subtitle, The Energy Transition Will Not Happen, and in English, More and More and More. Jean-Baptiste, welcome. Thank you so much for making the time to come on Decouple.
Thank you.
So to me, this is a really fascinating book. I've been deep diving energy now, not as an academic, but as a podcaster for some 5 years now. Pretty up to date in the English language histories, Václav Smil, Richard Rhodes, and others. And I encountered some pretty novel ideas in your book, which I'm excited to pour into. In this era of AI, of incredible translation, of the internet, I was really surprised that there's this almost like linguistic firewall around your ideas. We're about to bust through that on this program, and the book is out now. Again, I mentioned the provocative title in French. Maybe just to start, I was curious, this is such a sacred cow, perhaps a collective delusion, this idea of energy transition, of net zero. I'm just wondering, in terms of the English translation, was it too spicy to say, without transition, or it's not possible?
Basically, there was a banner called, in French, La transition n'aura pas lieu, the transition will not happen. It's the publisher who wanted to have this powerful words on the cover. I wanted a more academic title because I think the book is primarily history, even if I think history has something to tell about what is going to happen in the next 20 or 30 years. I was happy with the English title, More and More and More, an all-consuming history of energy. This is perfect. Because indeed the book tries to break this narrative which is so present even among the very good authors that you mentioned, like Václav Smil, Richard Rhodes. They have this narrative of several transitions happening in the past, several energy transitions. And my main point is about the history. We cannot really have any history of transition when you talk about the past of energy. I think it's a very wrong way to frame the history. For the English audience, I think the book is really an up-to-date contribution to the field of history of energy, first and foremost. And then the conclusion is about, what does it mean for the present days? But really, I want to emphasize the fact that it's primarily a history book.
And it's interesting. I've both been studying this space. I've also been an advocate within it, and discovering that I am an advocate or have been an advocate in the tradition of others. So really, really useful. We stand on the shoulders of giants to understand, the legacy from which we come. But this concept of energy transition, it's all over the discourse. I think you track in your book, with Google searches, how often it is used. It is assumed to be a truism. It's assumed to have a historic basis. Maybe a good place to start is interrogating this term. I think Smil and others will say, there are energy additions, and that's definitely part of the discourse in the Anglosphere. But I think, your novel contribution is really energy symbiosis as a better model to understand humanity's harnessing of different energy forms. So I'm eager to deep dive this concept. And it's a big chunk of your book. I think it really deserves to be. But I'll let you sort of take it where it's going to go. And definitely I'm going to be asking a few questions along the way.
Okay. So basically, when you take the history of energy, most of the time, what has interested historians is the competition between energy sources. I mean, it's really the core topic of so many books in history of energy. It's how coal has displaced wood in the 18th and 19th centuries Britain, or how oil has displaced coal. But in fact, focusing on competition between energy is just telling a small part of the story. In many respects, energy are helping each other. They're in symbiosis. I give you like a very famous example. If you take the Industrial Revolution, it is always told as a story of energy transition. And that's why sometimes, even in the political sphere, you've got people saying that what we have to do is a new industrial revolution. John Kerry, the US envoy on climate issues, is following the topic of climate change since the late 1970s. So he should know about that. He should know his history, I think. It's what he said recently. I mean, what we have to do is just a new industrial revolution. But behind this idea of new industrial revolution, you've got an understanding of the industrial revolution as a transition from traditional energies to coal, basically. And even this is completely wrong. I mean, first of all, traditional energies do expand during the 19th century. I mean, basically, industrial countries burn more wood in 1900 than they did in the early 1800s. And moreover, to extract coal, you need enormous amount of timber. For instance, if you take the case of Britain in the early 20th century used 4.5 million cubic meters of pit props. And to give you a point of comparison, Britain burned 3.6 million cubic meters of firewood in the 18th century. So just to produce energy, Britain used much more wood in the form of pit props than it did in the form of fuel wood in the 18th century. So that's why we really have to forget the story of, coal substituting to wood. It doesn't work like this at all. And it is even worse than that, because of course, to produce timber, you need a much larger area of forest. So it means that Britain used 4, 6, 7 times more forests in the 20th century, than it did in the 18th century. So you cannot tell a story of energy transition or an escape from an organic economy. That's another topic that you find very often in the historiography of the Industrial Revolution, but doesn't work at all, really.
So another symbiosis between coal and wood, obviously, we had the age of steam, we had locomotives, and I think people don't appreciate the amount of wood that was underneath the rails, the so-called sleepers. So maybe you could go on that a little bit, and then even creosote. Like there's so many examples of how these energy forms and raw materials are working with each other. So maybe expand on that a little bit.
Yeah, I mean, basically the case of coal mine, depending on timber, is just one example of that. All these technical systems that are emblematic of the Industrial Revolution that depended just as much on iron, coal, and they were also depending on timber. And the railroad is a very good example. If you take the case of the United States, late 19th century, they used more than 20 million cubic meters of railway ties, of sleepers. And that's an enormous amount of wood. It's like 10% of the US production of wood. It's several times more than the whole production of French forest, for instance. And I mean, basically the consumption of timber by US railway company was more expensive than buying locomotive, for instance. It's really a serious issue. And creosote is, I think, an interesting example of a kind of forgotten technology which had tremendous impact. Creosote is a substance derived from coal, from the distillation of coal. And you can impregnate timber with creosote, and that makes the timber last much, much longer. And that's how coal, in a way, protected the forest from the effect of coal, which were terrible, because all these coal technologies did consume more and more wood, and conservationists in the US were appalled by the enormous consumption of timber by the railways, by the paper industry, by the packaging, by the mines. And they're really worried about that. They were much more worried by the exhaustion of forest than by the exhaustion of coal, because they knew very well that coal was just immensely abundant, whereas forests are not that large. And close-out is one of the many technologies that help to protect forests from the bad effect of coal technology.
But that's interesting, because I think within Richard Rowe's work, for instance, we have the story that coal saved the forests in England, and so we're actually increasing lumber production significantly. And of course, this is within a globalizing world. So to what degree are the forests being saved by just imports from my country, Canada, or from Siberia, for instance?
Okay. I mean, the very large import of timber, they were on an Atlantic, I mean, across the Atlantic, it's really a 20th century story. If you take the case of Britain, which was the biggest timber importer in the 19th century, most of the timber came from the Baltic, or from the land plantation in Western France, kind of not very well-known story, but half of the pit props, beginning of the 20th century, came from one very large pine plantation, which was launched in the 1860s. And at the end of the 19th century, the trees were big enough to be used for pit props in Britain. So it is this kind of symbiosis, kind of combination of materials that make industrialization. It's not coal substituting to wood. It's really this entanglement of coal and wood which makes industrial modernity possible. And for instance, in most of the books you read, you have the idea that coal is a national resource, but in fact coal completely depends on an international commerce of timber. I mean, and for Britain, it was particularly clear that without all the timber from the Baltic, from Portugal, from France, they cannot have access to their coal. And it's a crucial issue during the First World War, during the Second World War. It is really a very strategic resource. So, I mean, you cannot have a history of the 20th century without timber. It doesn't work at all.
So we're going to move on, I guess, through these mythological transitions to coal from coal to oil. But we're going to keep forestry in the background because it continues to be relevant. So tell me how coal and oil symbiosis as it's added.
I think it's more obvious than the pit props. All the infrastructure of oil, from extraction to consumption, is based on steel. And steel is completely dependent on coal. I mean, you need coal to have steel. So basically, the expansion of the oil infrastructure makes that the steel industry is growing, and therefore the coal mines are stimulated by the consumption of oil. I mean, just to give you an example, to build a car in the 1930s, Ford needs 7 tons of coal, which in terms of weight is more than the oil that the car is going to burn across its lifetime. So, I mean, if you look at a car in the 1930s, it's just as much coal as oil, And there are calculations which are made on this particular topic. For the case of Britain, it is estimated in the interwar period that for each ton of oil that was burned, 2.5 tons of coal were needed to build infrastructure, the cars, the tankers, the pipes, all this needs an enormous amount of coal. So, of course, you cannot tell the story of the 20th century as a transition from oil to coal. I mean, it doesn't work at all. There are other, so basically what I try to argue is that instead of having a story of transition, we have a story of a symbiotic expansion of energies. And an example of that is the fact that if you take the oil industry in the US in the 21st century, it consumes more steel than the whole US economy in the 1900s, in the early 1900s, just the oil industry, because there are so many pipes. There's pipes everywhere. And we're talking about millions of tons of pipes, And of course, this steel for oil is expanding because oil is more difficult to get. You need to drill deeper. The oil has more sulfur, so it corrodes more all the infrastructure which is made of steel. The pipelines, of course, are much bigger, larger, longer. So, I mean, yeah, this is completely obvious when you look at the writing of the engineer that oil is not going to displace coal. I mean, there is a displacement of coal by oil just for a very short period of time between, I would say, 1959 to the oil shock of 1973. And this is mainly for the electric sector, for the production of electricity, for cement, a little bit. But otherwise, everybody knew that, steel would depend on coal forever. So like the engineers, the experts, the statisticians, even when they see oil, getting bigger and bigger, they know that coal will remain.
So a big part of, moving forward and at least, having large relative additions of new power sources is the underlying infrastructure. So for coal, obviously it's these mines, it's the pit props, it's the railroads to transport it, the steam engines to drain out the flooding of the coal mines. And people talk a lot about, the kind of supremacy of oil because it's a liquid hydrocarbon, it's incredibly energy dense. Being a liquid, it's actually quite easy to move around, but not until you have the infrastructure. So I want to talk about what I'm going to call one of the first gigafactories, which is the Rockefeller's wooden barrel factory. And we'll talk a little bit about the historic symbiosis of oil with wood in those examples, but there's some really interesting contemporary ones with regards to the suburbs. So let's hit up those two examples.
Yeah, well, the kind of small anecdote that makes history of tech funny, I think. The big age of the wooden barrel is like the 1910s, 1920s.
That late?
Because of oil. Oil in the US creates a new kind of wooden barrel manufacturers, heavily mechanized, huge factories. And indeed, the biggest wooden barrel manufacturers of the world is John D. Rockefeller, because he's also the biggest oil man, of course, of the early 20th century. And so you've got factories in the 1910, 1920s in the US producing more wooden barrels than all London at the same time, when London was, of course, the biggest port. So there was, of course, a very large cooperage industry in London. These wooden barrels were then exported to France, and they were washed and then used for the transportation of wine, this kind of serious problems. Anyway, so there's many kind of surprising connections between the materials. So the idea that oil is so wonderful because it is liquid, actually, no, it's a nightmare. It's a logistic nightmare because it leaks, and that's, of course, extremely labor intensive to prevent the leakage of barrels. And then, of course, until the 1930s, the derricks are made of wood. And derricks, they are kind of heavy infrastructure, like 30 tons at least. And there is almost 1 million oil wells which are drilled in the US before 1930. So it's a lot of wood, once again, So yes, this you really have to have a kind of systemic vision of the raw materials and energies. And one of the big defects, I think, in the historiography of energy, it is that it is written by specialists. You got specialists of coal, specialists of oil, specialists of timber, and they have not studied so much the interactions between these materials. They are monoenergetic.
Right. And that ability of a novel mode of transportation, the car, to open up a different kind of suburban environment. I found that fascinating, the actual physical symbiosis of oil and wood in the form of new construction materials that enabled, productivity revolution. Just go into that a little bit, because I just thought that was another unexpected symbiosis.
It's kind of obvious, but basically in the 20th century, in rich countries, the first the first use of wood is to produce energy, to burn the wood. That remained the first use of wood, sorry. And then the second is construction. The second sector is construction. The third is packaging. And both construction and packaging are driven by oil consumption. And the suburban environment, which is made possible by oil, of course, is of course a very strong, it opens very large market for timber, especially in the US and in Canada, where timber construction is very, very, very common. It's completely dominating, actually. Like 90% of the house in the US is timber framed. It's really a very, very big sector. And then there is a metamorphosis of wood. Just like with creosote, like coal transforming timber, wood has been completely transformed by oil, thanks to plywood, I don't know if I pronounce plywood, which is a kind of revolutionary materials. It's really increased the productivity in the construction industry radically. You've got also particle boards later, plasterboard. All these kind of neglected technologies have tremendous impact in the most important economic sector, which is construction. I mean, this is something that very often is kind of forgotten in history of capitalism or history of energy. Like the construction industry is the biggest industry. And it is where capital accumulates. If you take, in Europe, more than 50% of assets is housing. In the US, it's slightly less, but very close to 50%. So if you want to have a history of capitalism, you really need to talk about houses. And you need to talk about very basic technologies, such as plywood, plasterboard, concrete mixer, wheelbarrow, shovels. I mean, this is really what history of energy and capitalism is about, I think. And in the same way, if you take like the standard book in the history of energy, they're obsessed with engines, with new motors, the steam engine, the internal combustion engine. But in fact, housing is like 30% of energy consumption, 30% of CO2 emissions, So it's really a major sector.
So speaking of those engines, this is another interaction between oil and the forest, one of many. The chainsaw, the logging truck. I'm from the country of the lumberjack. I have ancestors that swung axes in the woods, but we had to move those logs down our great rivers. These fellows in striped shirts with nails on the bottom of their shoes, doing really dangerous work moving the logs just in the spring. That equation of sort of forest and timber product availability was dramatically altered by oil. So tell us a bit about that story.
I mean, once again, this is well known. I think there is a complete revolution in forestry after World War II, thanks to oil. The chainsaw, actually it's quite a late development. I mean, it's invented in 1927 in Germany, but it's really massively used only in the 1950s in the US and 1960s in Europe. Because chainsaws were expensive before the 1950s, and they were heavy, they were cumbersome. But then, starting from the 1950s and 60s, they are everywhere. And of course, it increased. The chainsaw increased productivity of the lumberjack quite radically. Then you've got other like skidders, forwarders. Special trucks that makes the moving of logs much easier. Then there are the forestry roads, which are very important. Actually, what makes the value of a forest? It's connection. So if you got a road, of course, then the wood is available. So all these technologies depend on oil. And then oil has also created a kind of new revolution in wood production, which is the forest plantation of eucalyptus. Quite a new phenomenon from the 1960s in Spain, Portugal, in Brazil, then in China, of course, in the 90s. And eucalyptus has really an incredible productivity. Like Brazilian plantations of eucalyptus, they can reach 40 cubic meters per year. Just to give you a point of comparison, like a normal forest in Europe in the early 20th century would be just 2 to 3 cubic meters per year. So you are producing 20 times more wood, And of course, it is possible thanks to oil. because you need fertilizers or gas fertilizers, you need nitrogens fertilizer to have these kind of productivities. So, like the eucalyptus plantation, on 3% of the forest area, they produce 30% of the woody biomass, and this is made for packaging. And packaging is another example of this kind of symbiosis, which are not present in the history of energy, but which are very important. Today, in rich countries, wood energy has increased a lot in Europe, in the US. And this in part due to the packaging industry and the paper industry. I mean, the paper industry is a very, very large industry. It's, economically, it's bigger than the aerospace industry, for instance, because packaging is everywhere, of course. And the paper industry is like the fourth industrial consumer of energy. So it's really, like the first is steel, of course, then you got cement, all the chemical industries, and then you got paper. And it is driven by packaging. And from the 1960s, they start to use the black liquors, which is a residue of paper production, to energize their machines.
Are we burning more wood than ever? Are we at that peak as well?
Oh no, I mean, wood has expanded a lot in the 20th century. It keeps expanding. So just the black liquors right now in Europe produces more energy than solar. In US, it is quite recently that wind power has overpassed the black liquors. No, we are talking about some serious, black liquors is not marginal, it's very big. And today in Europe, wood energy is 3 times bigger than solar, wind power and hydraulic energy in terms of primary energy. So no, I mean, we're not talking about marginal things. And that's a very classic distortion. We are obsessed with the novelty. So solar panel is going to make the front page, but wood energy, we're not going to talk about it. Whereas it's much, much more important for the moment. I'm not saying that like in 20 years, probably solar will be bigger, but for the moment, wood energy is a very, very serious thing. And I'm talking about the rich countries. If you talk about the poor countries, of course, wood energy is enormous. I mean, wood energy nowadays provides energy for cooking, for getting warm, to more than 2 billion people. In terms of final energy, it's bigger than nuclear energy. And for instance, there has been a very strong expansion of charcoal in poor countries in the 1960s. Actually, the first time in the history of humanity that you've got cities, more than 10 million inhabitant cities that are using charcoal to cook their food. Like a large African city like Lagos or Dar es Salaam, they can burn more than 2 million tons of charcoal a year. Paris in the 1860s was just 100,000 tons a year. So it's another order of magnitude. So, I mean, really, wood energy is very new. It's very recent. It's nowadays that we are burning more wood, that we are burning the most coal, the most oil.
Right. So there's also this kind of narratives of progress and, the march of time, right? And we're going to get into Cesare Marchetti and some of that stuff a little bit later. But, we think that these transitions are just moving in one direction. And we have a few examples of that going backwards, one with wood. And, maybe this is just distortions of subsidies and the way that we will label certain sources low carbon, but just tell us a bit about the Drax power plant in the UK, because I thought that was a really interesting example.
Yeah, it's a funny example because, of course, so Drax, first of all, Drax is a coal power plant, which was converted to biomass around the year 2000 with a lot of subsidies. You're right, actually. And of course, the pretext was climate change. But biomass is a code name for wood which is extracted from Canada and from the US. It is, of course, transported to Britain with boats using diesel. But, I mean, the striking thing is the quantity of wood. We are talking about more than 10 million tons of wood per year, which is 4 times more than what Britain burned in the 18th century in just one power plant. So we reached the great result that after 2 centuries of energy transition, Britain, which is of course the leading countries of energy transition, the first industrialized country and the first country getting out of fossil fuels. I mean, they pretend actually. Britain used 4 times more wood to produce their energy now than in the 18th century. And just to produce 1.5% of their energy. Because it's, I mean, compared to all the energy, of course, it's not that big. And I think this example shows, of course, the fact that the project of using biomass to have the same kind of economy that we created with fossil fuels is going nowhere. It won't work. There is not just enough biomass to do that. I mean, you got the same kind of issue about sustainable aviation fuels, which are very popular at the European Commission. There are incentives for the aviation companies to use sustainable aviation fuels. If you take the case of France burns each year 9 million tons of jet fuels, and the whole production of oil in France is 2 million tons, and oil is the best substance to make jet fuels. So I mean, there is not enough biomass to do that. It just doesn't work.
Forests are also really leaned upon in climate models as really integral part, particularly in this desperation. And it's well-meaning. I get it. I share it. I like the Holocene. I would like to lower our ppm of CO2 a little bit, but it leads to some pretty magical thinking and really like collective delusions, which I think your book is doing the important work. It's jarring. There's some cognitive dissonance, but I do. I'm not a fan of the bliss of ignorance. But again, tell us a little bit about. We have big plans for bioenergy, carbon capture, and storage. You talked about the incredible productivity of the eucalyptus plantations. So we want to get off of fossil fuels, and we want to use forests as carbon sinks. Why doesn't this quite work out?
Well, there are several issues. First of all, wood, just like the other energy, is in symbiosis with oil. I mean, I mentioned the chainsaw, the trucks, and so on. If you look at the literature, the forestry literature, you can say that basically between 1 to 2 liters of diesel is required to produce 1 cubic meter of wood. So when we are talking about, like a carbon neutral energy, this is just false. I mean, in a very simple way. And then there is the issue of negative emission with forest. And I mean, it's really at the end of the book that I reached this issue. In the integrated assessment models, which are used to create scenarios of net zero by 2050 or 2070, basically the modelers need a lot of negative emissions. When I say a lot, it's really a lot. In the last IPCC report of the Group 3, the one which is looking at solutions, it's a 2022 report. If I remember correctly, across the different range of scenarios, you need to store by 2100 between 170 gigatons of CO2 to 900 gigatons of CO2. Sorry, there are a lot of numbers, but just to give you a comparison, it's several times more the production of food today that you would need to put in the ground. To do that, they use BECCS, bioenergy carbon capture and storage. You produce electricity with wood, you capture the CO2 at the exit of the chimneys, and then you bury that under the ground. I mean, a technology that doesn't exist, that is completely non-competitive. Dracs, I mean, normally Dracs should be equipped with carbon capture and storage equipment, and they don't have it because it just breaks all the, I mean, you need a lot of electricity to capture the CO2. Basically, if you want to do carbon capture and storage, you need to, for three power plants, you need to build a fourth power plant to produce the electricity to capture the CO2. So it's rubbish, that won't exist. And that's really something which troubles me a lot. Like, what is the political meaning of these scenarios? What do they do to the public discussion on climate change? I think that they create more illusion and procrastination than anything else. Because the result of that is how the science has the scenarios to get us to net zero by 2050. You just have to listen to the scientists. But when you look at their reports, they are completely, imaginary. They are using technologies that are not scalable, that are not competitive. I mean, for the BECCS, there were articles showing that to produce enough wood to capture all these gigatons of CO2, you would need plantations of the size of 3 times India. Of plantations of fast-growing trees to produce the biomass that would produce the electricity that then would be. There is a serious issue here.
Presumably, again, those fast-growing trees are dependent upon fossil fuel inputs, Haber-Bosch, nitrogen. Yeah, so there is no disentangling or escaping from these symbioses. One of the phrases in your book is basically that raw materials and energy sources they don't go out of fashion. Again, we use more and more and more. There are, however, I can't remember. It's like a tiny handful, maybe only 5 raw materials that we're using less of. One of them actually is doing something good for the forests. So to tell us about that, the wool. That was interesting.
Wool. Yeah, right. Yeah. Okay. Yeah. I mean, that's a very, very obvious fact. I mean, it's really at the beginning of the book, I explained that why people have talked about transition. I think they have projected a model, an intellectual model of the S-curve diffusion of technologies on the issue of energy or materials. But that doesn't work like this. I mean, technology do become obsolete sometimes, but raw materials are never obsolete. It's a very obvious point, I think. There is one raw material that has decreased, and it is wool, indeed, sheep wool, because of oil, actually, because we've got synthetic fibers. Another example would be asbestos, because there were prohibitions in certain countries, and that, of course, makes the global consumption decrease. But otherwise, despite all the innovations, and especially in organic chemistry, there are so many new products, new substances. Raw materials always increase. I mean, that's really a very, very, I think, disturbing empirical fact that needs to be taken into account when we talk too lightly about, innovation, disruptive innovation, and all this rubbish to solve our environmental issues. This is really, really very strange discourse.
And some of the narratives common amongst those of the kind of eco-modernist persuasion, that response to these environmental questions of limits. Again, one of them is, that, this transition to coal, to more energy-dense fuels, saved the forests. And I think you've pretty decisively demonstrated that is not true. But there's another great mythology, and that's about how the oilmen of Texas saved the whales. So it's a nice story, but it turns out maybe it's not true.
Yeah, this is a very old story. I mean, I put a caricature of 1860 something where you got the whales giving a toast to the discovery of oil in Pennsylvania in 1861. Because, of course, supposedly oil would save the whales. And then the story is really repeated by the oil industry from the 1930s onward. When we talk about the environmental effect of oil industry, they always say, "Oh no, we are the good guys. We have saved the whales." And of course, it is so stupid. I mean, just a few elements, like 3 times more whales were killed in the 20th century than in the 19th century. And they were killed with boats, much more powerful boats using diesel engine. So oil was, of course, very useful to kill whales. And then the funniest part, I think, is that the very last drops of spermaceti oil were probably used in jet engine, because it's an excellent lubricant. And they were also used in automatic cars. Like for very good lubricant, you need a small part of whale oil, which has very interesting property that I cannot explain. But So yeah, of course, this is rubbish. And if something saved the whales, it is first of all Greenpeace, I think, like the environmentalist movement and some kind of radical environmentalism, and the Jojo battery. Not a very well-known character in the story, but it's a tree, I think, growing in Mexico primarily, and then which was cultivated in Israel, and they make plantation of jojoba battery to replace the lubricant that were derived from whale oil. So yes, no, the oil did not save the whale. Of course, it's a funny story, but the very sad thing is that the experts and the economists, experts on climate change, like William Nordhaus, they buy the story. And they repeat the story all the time. William Nordhaus, one of the important characters in my book, Nobel Prize in 2018 for his work on the economics of climate change. You find that in his articles. Of course, it's through innovation that we will save climate, just as it is with oil that we save the whales. So this kind of mythology, they are even present among the people who should know, I think.
Okay, so we've, I think, covered, not exhaustively, because there's more in the book. Buy the book. It's an incredible book. But I think we've covered the symbiosis chapter of this episode. Let's talk a bit. You mentioned, I think, part of the rationale as to why this has been missed, and there's been this phasist history of energy, people being siloed. That's becoming more and more common, I think, in our modern world as things become more complex. But let's talk about, how these ideas became to be dominant, and particularly the idea of the energy transition. As a bit of a nuclear fanatic, I was really surprised that the term energy transition actually originates with nuclear scientists. So maybe start us off there as we branch into chapter 2 of this episode.
Yeah. So, the second part is really about how basically you can't tell the story of energy talking about transition. So how it became so dominant. It's kind of an obvious question, the first thing to be noticed is that it's a fairly recent concept. For the most part of the 20th century, experts would comment on energy dynamics without using the word energy transition, because obviously there was no energy transition. There is one group of scientists who start to talk about energy in a different way, and they are the atomic scientists. And there are a small group of atomic scientists. They are the members of the Manhattan Project, and they were working at the metallurgical laboratory in Chicago during the Manhattan Project, and they were amazed by the quantity of energy that you can get out of uranium if you got the breeder reactor, the fast neutron reactor. This is really a key thing. The nuclear they wanted, the nuclear energy they wanted is not the fission that we have, is another kind of nuclear energy, is the breeder reactor. And it is true that in theory you can have access to hundreds of thousands of years of energy if you have the breeder reactor, because you burn all sorts of isotopes, the U-235, the U-238. So it gives you kind of infinite temporal horizon. And for those atomic scientists, it was a very important argument, because it demonstrated that what they did was not just a terrible instrument of death, it was also a key technology to save industrial civilization in the very long term. Mm-hmm. And so they are really thinking about energy not in decades, not even in centuries, but in millennia. That's really something very particular to these nuclear scientists that the other people didn't do at that time. And it is also for this reason that they are really among the first to study properly climate change. I think this is something new in the book. I show the importance of the Atomic Energy Commission, the US Atomic Energy Commission, for the first serious studies of climate change. It's because they have new instruments. They have what is called a mass spectrographer. I'm not going to enter into many details, but basically it allows you to have paleo temperatures using the isotopes of oxygen. And also they have a very good argument, because of course climate change is a very strong argument to promote nuclear energy. And as soon as 1953, it's very early on, there is a report by the Atomic Energy Commission saying that there is an issue with climate change and we have to study that. The guy who coins the word energy transition is an atomic scientist called Harrison Brown, a very interesting character. He's also a leading Malthusian. He's obsessed with the problem of demographic growth. And atomic energy is a way to solve this problem of demographic growth. And in a way, energy transition is actually a word coming from atomic physics. It's a change of an electron around its nucleus. And so Harrison Brown is just recycling his own expertise to talk about energy and the future of energy. And so, yes, energy transition is really rooted into this atomic expertise and this promotion of atomic energy. But what I like about these atomic scientists is that they recognize that, it won't happen tomorrow, especially at a global scale. When you look at their graphs, there's a very famous graph by Marion King Hubbert with the theoretician of peak oil. He's not an atomic scientist. He's a geologist, but from 1955 onward, he's recruited by the Atomic Energy Commission, and he becomes an important lobbyist for the Atomic Energy Commission. But when you look really, cautiously at what he's saying, basically, in the US, it's going to go quite quickly. By 2020, there will be no more oil in the US. Not a very good guess, anyway.
But conventional oil did peak when he called it in.
Yeah, it is true. That conventional oil peaked when he said 1970 something. Yeah, that's right. But for the whole world, they know there is a lot of coal, so they see the end of fossil fuels in 3 or 4 centuries. The energy transition will be achieved, will be finished, will be over in the 23rd or 24th century. And what I try to explain in the last part of the book is how come that this very strange futurology of entirely shifting from one energy source to another, which is radically strange, radically heterodoxical. It's not in this way that normal experts on energy really thought about energy. How come that this very strange futurology became the dominant futurology? And there is a kind of scientific scandal, I think, that we recycled a notion, energy transition, which was supposed to take place in 3 or 4 centuries, and which was driven by the increasing price of fossil fuels, because it was the growing scarcity of coal that would make nuclear energy competitive, and that it would prevail because coal would be too expensive to be mined, right? We have transferred this futurology for climate change, which is a completely different problem. We have to go out to get out of fossil fuel not in 3 or 4 centuries, but in 3 or 4 decades. We have to do that globally, and we have to do that without the price incentive, because coal is still very cheap, compared to even to solar energy. If you take into account the intermittent character of solar energy, coal is cheaper. So it's really a strange story. I think that the expert accepted this idea of energy transition, whereas it was certainly not mainstream in 1970.
So, part of the naivete of the thinking here in terms of replacement it comes down to, I guess, questions of energy fungibility. The reason that wood persists is because it has a series of properties to it. Coal similarly, you can store large amounts of it. It's a solid, it's cheap, etc. It has chemical properties that you can harness, much more so with oil. But it feels like because of the way that we measure energy, that's part of what leads into this slightly delusional thinking. So kilowatt hours, British thermal units. Is that a kind of big part of the story, just in terms of the historiography?
First of all, we have taken for granted the fact that coal was just coal, but in fact, coal is a lot of wood, for instance, and oil is not just oil; it's plenty of coal to produce the steel and so on. So there is this aspect, and the other reason for the success of this fungibility imagination of around energy is the obsession with electricity. If the atomic scientists talk about energy transition, it's also because what they have in mind is, of course, the production of electricity. And it is true that for the production of electricity, there is, yes, a part of fungibility. Nuclear energy can replace coal for the production of electricity, indeed. But production of electricity is just one part of the problem, just one part of the energy production. and just one part, like 40% of CO2 emissions. So I think we have also projected on all the rest, imaginaries, discourses that were invented to reflect upon the market of electricity production.
So this was another, wasn't a major focus of the book, but in terms again of this history of energy, and someone who has advocated very strongly for nuclear energy on a variety of measures, partially caught up in this delusion of energy transition. There was this moment of kind of utopian thinking about hydroelectricity. This was really, I guess, when the electric age was kind of beginning. But I'd love it if you could just delve into that briefly as a little tangent.
Yeah, among the ancestors of the idea of energy transition, they didn't use the word energy transition, but they had this idea that, like around 1900s, that in the future all energy would come from electricity, and this electricity would be produced with hydraulic energy. It is very present among a very influential historian called Lewis Mumford. Lewis Mumford is really a very influential figure in history of tech, in the US in particular. He's seen as a very serious author, but when you read his book, called, I forgot the title, the 1932 books, Techniques and Civilization, the 1932 book, is saying very strange things, for him that hydroelectricity will replace completely coal. But like 20 years before, the statisticians were showing that no, hydroelectricity has a lot of potential, but it cannot replace entirely coal. It's rather seen as something that which allow to economize coal, but not to replace it. And also he has this very stagist vision of history. So there is the Eotechnic age, which was wind power, hydropower. Then there is the Paleotechnic age, which is coal, and the Neotechnic age, which is electricity produced with hydraulic energy. And he has these very strange words, like he's surprised that there is still wood in the age of iron, for instance. So he's part of this stagist narrative of the material history of humanity, which is created at the turn of the beginning of the 20th century, in part because people are really amazed by electricity. And it's true, it's an amazing technology. Among all the technologies of it's difficult to imagine a world without electricity. So, of course, it's a very important technology, but, all the rubbish about the electrical age. And then we had the same thing with the atomic age in the 1950s. The same errors, the same misconceptions about, this new technology, which is going to change everything. We have it all over the place with AI. We have that again. It's part of the hype around innovations, which is very powerful. And the problem is that this very strong emphasis on innovation has been replicated in history. And on this key point, I was really inspired by a very important historian of tech called David Edgerton, a British colleague, who has written a wonderful book called The Shock of the Old. It was 2006, if I remember correctly, and it was really a very important source of inspiration for my own work on energy.
So, there's this kind of utopian element to it, and I think, net zero is a bit of a utopia, right? Climate stabilization. The hydroelectric age was, we're going to clean up the skies, there wouldn't be air pollution, get people out of cities, change, the relationships of workers and capitalists, et cetera. When it came to these atomic Malthusians, they were specifically imagining the breeder reactor, making the deserts bloom, for instance. So, yes, speak a bit about that, because I thought that was pretty fascinating. And also, again, on this question of fungibility, a recognition that, okay, electricity can't do it all. We've got to use nuclear to basically replace all the other stuff. And to do that, we need hydrogen. So I think this gets us to Cesare Marchetti.
New technologies are very often old story of repetition and hypes, indeed. So for the case of the atomic age and solving the problem of demographic growth, the atomic scientists that I mentioned were Malthusians, and they explained that with atomic energy you can mass produce fertilizers, nitrogen, you can desalinate water, the water of the oceans, and you can also recycle the phosphorus which is dissolved in the oceans. There is like a few ppm per cubic meters of phosphorus, but you got so much energy that you can do whatever you want, basically. And so you can open to cultivation the vast arid land of the planet, and you can solve the problem of producing food and solve famines and so on. It was really actually important in the US in the 1960s because under the Johnson presidency, there was this idea that to fight communism, you need to control demographic growth in poor countries. Demographic growth would create poverty and therefore revolutions, and would be bad for the West. And so Harrison Brown, he gets subsidies from the State Department to study these problems. And the hydrogen example, that's an interesting case, I think, because of course nowadays hydrogen is seen as one of the key element of the energy transition to and the path to net zero. It was first promoted by a very interesting character called Cesare Marchetti. He's an Italian atomic scientist working with General Electric in the US and at Euratom in Europe. And from the early 1960s, he explained that hydrogen is absolutely indispensable if you want nuclear energy to become important. He's a very strong promoter of nuclear energy. And if nuclear energy is constrained in the market of electricity production, it will remain small. So what you need is to produce hydrogen to replace oil. And then you start to become serious, So he has this fantastic project of building huge nuclear plants in the middle of the oceans, because in the middle of oceans, people would not complain. And the people were afraid about the thermal effect of nuclear production. It would create so much heat that it would be terrible for the environment. So if you build them in the middle of the Pacific Oceans, you can cool the reactor properly. And for instance, he said that Japan would become like the new Saudi Arabia, thanks to this nuclear plant in the middle of the Pacific Ocean. For the nuclear residues, they are so hot that they would self-sink in the floor, on the ocean's floor. So yeah, he has a kind of Dr. Folamour character. But at the same time,
and these were like 20 gigawatt nuclear stations in Pacific atolls. Yeah, and I guess that
on barges, they were floating nuclear plants. Yeah.
Right. And I mean, but we hear that now. I mean, we hear about Australia becoming the Saudi Arabia of hydrogen because of, its incredible solar resources. So this stuff is not, what was the title of the book again? It's stuff is old, right?
No, it never dies. So is this kind of, of like atomic scientist with grand vision, but at the same time is kind of rigorous because he's really worried about the time that this atomic utopia would take. And is the author of extremely famous curves, like wave curves. I mean, if you know a little bit about history of energy, it's a very influential vision of energy. You put all the energy sources in shares, in relative terms, and you trace curves, and you see nice logistic curves of diffusion and replacement. And he understands or explains that, energy transition will take time, a lot of time. And it's an interesting argument because why he's doing this to discuss his colleagues' work, futurologists, forecasters, who are using computer models to show that, yes, you can get out of fossil fuels in 50 years. This is exactly the same. I mean, the same goal that we have now. But in 1972, it was the goal that was fixed for a group of researchers at IIASA. IIASA is International Institute for Applied System Analysis, an extremely important group of researchers in terms of energy modeling near Vienna in Austria. It's an international institution, and they are using the first computer models to produce the integrated assessment models. We're talking about models that were elaborated in 1972, and they are still used today. That's something which, I was really struck when I discovered that. basically the YASA made the first energy models that are still used by the IPCC Group 3 to reflect on the future of energy. And these models demonstrated that there were soft transition paths out of fossil fuels in 50 years. And Marchetti was saying, no, don't believe that. And he was using history of energy, to show that, it takes a lot of time. And the most depressing thing is, Marchetti was the most pessimistic guy of his times. And he was far too optimistic. For him, coal would have disappeared by 2020, for instance. And you were mentioning Václav Smil at the beginning of the talk. Václav Smil has criticized Marchetti, saying that this is rubbish. Look, coal is still very important. But it's quite unfair, because Marchetti, was the most pessimistic guy among very optimistic people at YASA. And even the most pessimistic guy turned out to be far too optimistic about our ability to get out of coal.
What's fascinating again is these examples of sort of, again, in this terms of historiography of progress and moving. Well, Marchetti talked about this, right? Moving from longer hydrocarbon chains, getting rid of the carbon to hydrogen ratio, shrinking until we're just using hydrogen. But as a product of the oil crisis, we have a march backwards in history, a detransition, if you will, back to coal. And I think maybe Marchetti wasn't anticipating the rise of India and China. Can you talk about just the extraordinary return to coal and how that upset his vision?
Yes, that's something that it was anticipated among some people, the fact that the big expansion of coal will be in China, and I think that's really a key issue to understand why so little was done about climate change in the late 70s. It's really at the end of the book, I study, how in the US, all these questions were already on the table in the late 70s. There is the Charney report in 1979 about climate change. They show that the climate sensibility is 2.5 degrees. So they have a very good approximation of the effect of the doubling of the CO2 content of the atmosphere. There is no climato-skeptics at that time. Even Exxon is, saying, yes, of course, there is climate change. And I think part of the reason why the US government kind of buried the issue, well, first there is Reagan, of course, which is an important cause of, forgetting about this issue, the Reagan presidency, but it is also the fact that they knew that China would become the first emitter in a very short time. In 1979, there is an international conference on coal. Interestingly enough, it is led by Carroll Wilson. Carroll Wilson is the first head of the Atomic Energy Commission, a very strong promoter of atomic energy. He pushed the issue of climate change in the 1970s. And then at the end of the 1970s, he's very disappointed with the success of nuclear energy. There is not so many reactors that have been built, and he thinks that the Westinghouse model is not that good. So he said that we have to expand coal to answer the growing demand of electricity in the poor world. So he organized an international conference. The Chinese representative said that by the year 2000, we expect China to burn 3 gigatons of coal, which is more than the whole world consumption of coal in 1979. So, it was obvious that the climate change would happen, even if the US were trying to have any kind of climate policy, it would not change so much. So there is a very strong sense of resignation in the late 70s, early 80s. The same thing happened in Britain. There is a very interesting archive in the Thatcher cabinet of 1989. Margaret Thatcher organized a meeting with all his cabinet members, and one after the other, they explained that basically, yes, there is climate change, of course, but you can't do much. Because, for the transport minister says, yes, you could increase the offer of public transportation, but it's not clear that people would just drop their car and use autobuses. Might not work like that. The only thing that you can do is put very high taxes on oil, on gasoline, but frankly, you don't want to do that. It's not very popular. And the Ministry of Energy says, Britain is 3% of CO2 emissions. In a few decades, in 2 or 3 decades, will be just 1%, so we can't do much. And the best that we can hope is that we will adapt. And another key reason why very little was done, or nothing was done at all, actually, on climate change at that time, it's not for the climato-skeptics. I don't buy this story. I think they're not that influential. It's the trust in the fact that rich countries can adapt. I mean, another, I think, discovery that really amazed me is the fact that as early as 1976, in the US, there are discussions about adaptation to climate change. 1976, there is a colloquium organized, Living with Climate Change. And basically the issue is, of course, there is climate change. We can't do much. Is it really bad for the US? Well, for the US, 3 degrees is completely acceptable. It's a very large country. You can move agricultural production according to climate change. You will have new seeds. GMOs is very fashionable at that time. And there is a very strong cynicism because they explain that for poor countries it will be much, much harder. Yeah.
Right. So part of the story is, one of absolute versus relative transitions. There's certainly like local examples of transitions. I'm from Ontario in Canada. We outstripped our hydroelectric potential very early on in the development of our province, started building a lot of coal. We don't have our own coal, so we're importing it, much like France, not having its own coal and going nuclear. And so those are certainly pretty convincing examples and maybe pushbacks on energy transition. And I guess some people would say, poor countries are still using coal because they're poor. And as they get richer, they'll transition to gas, and we'll have, Marchetti's march towards the promised land of eliminating carbon altogether from energy systems and just doing hydrogen. Is that I don't know, is there anything to that?
I mean, in a very long term, why not? But if you look at Marchetti curves, it's somewhere in the 22nd century, that I think we are really out of fossil fuels and natural gas. So it's much, much, much too slow for the climate issue. So no, I think the more reasonable is to say that, we cannot count on the fast diffusion of nuclear at a global level because it's expensive, complicated. There are very few companies that can build nuclear plants. It's a key thing. In France, they want to build 6 nuclear reactors or 8 new nuclear reactors. And EDF said we can't do more, actually. It's really the maximum that we can do before 2050, because it's very complicated civil engineering. And each reactor is kind of unique. It's a very big construction site. You need cranes. You need, I've talked about that with François Morin, that you know, who is a very good expert on nuclear energy and a very strong promoter of nuclear energy. But he recognized the fact that we are talking about, very serious civil construction that is not reachable in many countries, I think. So no, the Marchetti utopia was a very long-term utopia, and that's why it was. It was what he wanted to say: be reasonable. Basically, he was saying that because YASA was completely obsessed with nuclear and with breeder reactor. The chief of YASA was Wolf Affele, who was the chief of the breeder reactor program in Germany. And they're a very strong promoter of nuclear energy. Marchetti was also a strong promoter of nuclear energy, but he had a better sense of, the inertia of the system.
Right. And, your book is called More and More and More. Unfortunately, the only less there is in terms of these sources of primary energy is nuclear. You mentioned biomass. The only less is nuclear. We've dropped in terms of our percentage of primary energy of nuclear, even in absolute terms. And in Western countries,
it's reverse. To reverse, China is building dozens of nuclear reactors, so it will work.
It's a temporary setback. It may be political. In terms of that resignation to adaptation, there was a EPA report you mentioned, I think from 1983, which was looking at, okay, if we ban shale oil and coal, we might be able to delay a temperature rise by a certain number of years. It wasn't, I don't remember the exact numbers, but it wasn't all that heartening. Is there more up-to-date research, or we don't do that research because it gives us such pessimistic answers? Tell us about that report and the impact it had.
Okay, I can talk about the 1983 report, which is, of course, completely depressing. I mean, basically, they are playing with computer models of energy, global energy mix. And they say, okay, if we put like a 300% tax on coal, which is quite big, by the year 2000, it delays the 2 degree Celsius rise of temperature by, I can't remember, like 10 years, perhaps 15 years at most. So basically, in the US, they understand that the only thing you can do is delaying the problem. You cannot solve it, which I think is it's quite an important thing to have in mind. We are buying time, basically,
and not a lot of time. Not a lot in terms of the kind of pace of adaptation that's required. And certainly we have we mentioned William Nordhaus, his damage function, his DICE, I forget what it stands for, but this kind of economic models of climate change, and that I think 3.5 degrees Celsius is the ideal temperature for the planet because of
the optimal temperature is 3.5. Yeah, but it has been so criticized, and I think he has even himself said that, okay, I was wrong. I mean the damage are much bigger for each degree of rise of temperature. We're talking about 10% GDP now. I mean, something different. Yeah, I mean it has been completely revised, this model, but that not prevented him of getting Nobel Prize, which is another problem.
Right. So, where does this leave us? Reading your book, again, I have read it 3 times. It's fascinating. It feels really novel. Again, I don't feel like these ideas of symbiosis have made it into the Anglosphere, and I don't think your deep study of the history of the concept is here. It's a disruptive idea. It's disquieting. Frankly, it's doesn't leave one in a terribly optimistic state. It's the truth, I think, as far as I can tell. Adaptation does seem like something that we need to be thinking quite seriously about. But it sounds like you're not too hopeful that innovation can save the day and arrive in time.
The book is it's about arriving in time. I mean, that's the key thing. I mean, you have to take into account the diffusion of technologies that takes time. And I think, nowadays the technofix approach is more pushed by promoter of solar energy and wind power. And I think these technologies are important because they are cheap. Not wind power, but solar is cheap. So it can be implemented quickly, but it has many defects. And I think it's important to recognize that it has also limitations. So basically what we will have in the next decade, it's basically what the reports of the International Energy Agency are saying. We will have probably a kind of flattening of the emissions. Coal might even decrease in the next decades, not disappear, but decrease, thanks to solar energy mainly, because it allows to reduce the factor de charge.
Yeah, I guess like the fuel sparing. Yeah.
Exactly, of the coal plants in China or India and so on. So that's good news, but it's far from net zero, right? And for gas and oil, it remains stable, or even it depends on the growth of India. If India is growing like 6-7% like China, then oil and gas will increase. So what I'm saying is completely mainstream. You say it's disquieting, but in fact it's completely mainstream. What is really marginal and strange is the net zero. What is mainstream is what the International Energy Agency is explaining, or what the American equivalent is saying. It's the same thing, more or less, slightly even more pessimistic actually in the US. Anyway, so I think, it's reasonable to think that these forecasters, they cannot be so wrong that will be net zero without knowing it by 2050 or 2070. I think this is a very, very dangerous guess. So what we have to talk about is adaptation, is key. And then we have to talk about sufficiency and degrowth. I think part of the aim of the book is to show that these topics, which have been completely neglected by economists, should be taken more seriously. And all the expertise on climate change, which is so geared towards a technological solution. If you take the last report of the IPCC Group 3, I made some counting of words. Transition is like at every page. Sufficiency is just appearing now. And it's still very small. It is their sixth report. It's been 30 years that they have studied what we have to do for climate change. And it is only now that they're starting to talk about sufficiency. Mm-hmm. Last March, for the first time, there was an article using an integrated assessment models to show what economic stagnation or economic degrowth, how it helps to decrease the CO2 emission. It was for Australia, which is a rich country, right? And of course, it makes things easier. I'm not saying this is the solution, because I don't think there is a solution, but it should be studied more properly, I think, and not be left to some marginal, environmentalist, dangerous eco warriors. No, it should be what the discussion is about. Is, there will be CO2 in the economy by 2050 for sure. So where do we put it? In which sector, in which country? I think that should be the center of the discussion, with the increase of clean electricity, of course. But
yeah. I mean, it's interesting. I have a colleague who talks. He probably has a bias towards degrowth, but he recognizes its complete political unviability. So he talks about eventual sort of post growth, and he's someone who's in the peak oil camp. Again, gonna arrive too late and probably be pretty horrific, based upon the sort of debts we've run up and the need for growth to be able to finance those debts. Okay, well, I think we'll leave it there for now. Again, absolutely fascinating book. I can't endorse it more highly. Coming out, unfortunately, in the English world, I read the French version, and then I discovered I can use Google Translate within Kindle. I had to translate little paragraphs at a time. It was excruciating. But how long do we have to wait? Those of us who are not journalists to get this book.
Penguin is going to publish it in Britain in October 24. And I think in the US, it's slightly later. It will be January 25, something like that.
Yeah. What's next for you? What are you working on now?
Basically, this idea of symbiosis, I want to expand it on the human muscle, and to talk more about agriculture, and to talk more about the modernization of the human muscle energy. And look at all sorts of technologies which are not, central, but like the shovel, the spade, the wheelbarrow, some basic technology which were very important to understand for the 20th century.
Mm-hmm, mm-hmm. And of course, there's all of the symbioses of so-called renewables technologies. Lots to discover. Okay, well, thank you again for your time, Jean-Baptiste. Wish you well, and welcome to the Anglosphere. There's I think 2 or 3 YouTube videos of you presenting to some faculties around Europe, but it is amazing how insulated you and your ideas are by that little linguistic barrier. So glad you're breaking through.
Thank you very much, Chris.
You're welcome.